Okay, good afternoon. We're good to go on to our next session. It's going to be a 20-minute presentation on optimizing IP address management with open source CNI plugin. And this presentation will be given to us by Parth Goswami, a custom enablement engineer at Cloudera. So he's an open source enthusiast and works mostly with containers and networking. And he loves contributing to open source and hosting meetups and interacting with the community. So thanks for being here. Parth, over to you.
Thank you.
And a round of applause.
So we are almost at the business end of this event. So I hope you have had a good conference so far, good, fruitful, and productive. I am not habituated with mics, so yeah, I'm gradually getting habituated. So please excuse me and bear with me if my pitch drops suddenly or there is a spike. All right. So I work for Cloudera as a customer enablement engineer, and today I'm going to talk about adapting open source CNI plugins for IPAM. Before I start my talk, I wanted to understand like how many of us are students over here? Can you just with a raise of hands? All right. And how many of you have some sort of networking background, like work with platform networking or container networking? All right, cool. I see a few hands. That makes my job easier. So again, before I start my talk, I just, based on my experience, again, don't quote me on this, but what I've seen is students usually stay away from networking. They try to skip networking. Maybe they don't see the value in it. They run away from networking for so and so reasons. And networking is one such aspect that gets left behind, right? Now, if you try to start at the very bare metal level and then go like above the bare metal level, that is your hypervisor is there, and then top of that your virtual machines are there, and then if you are in the microservices environment, on top of your virtual machines you have OS and then the container layer, and then if you are also orchestrating that, you have another orchestration layer, and then finally you have the pods and the containers inside, right? So the one aspect that would bind the entire stack is networking. So networking is something that's very important, very essential. So this is a very small attempt from my end to simplify networking and to ensure that that we understand networking to its core. So the approach that I'm going to follow is I'm just trying to break down these heavy words, heavy terminologies. So I would assume all of us to be very much familiar with the first two words, adapting open source. Now, I'll start by defining what CNI itself is, what plugins are, what IPAM is, and then we'll try to understand why there is a need for adapting open source CNI plugins for IPAM in the Kubernetes space. All right, so this is the agenda. I'll maybe skip that in the interest of time. All right, so let's start with the definition of CNI. This is the definition officially given by CNCF. That is, it is a specification, it is a specification that defines how to configure networking for Linux containers. The way it does that is by providing APIs for networking solutions to be integrated with container runtimes of your choice. So it doesn't matter if it is a X container runtime or a Y container runtime. It can be anything of your choice. And so just look at this diagram and try to picture this diagram from the bottom-up approach. So you have container runtime at the very bottom, the layer, the container runtime, and then on top of that sits the CNI layer, right? And then the CNI layer ships a lot of plugins with it. Those are, some of them are inbuilt, like we have loopback, bridge, MacVLAN, and then most of them nowadays are third party, and it is essential for the clusters, for the enterprises, for the administrators to network admins basically to use third party network plugins. Now, this talk entirely is designed or the attempt is to understand the need to go towards third-party plugins, and there are various lots of purely open source third-party plugins available, CNI plugins available. So yeah, eventually we'll try to understand why there is a need and what all options we have in the market today so that we can make better use of those CNI plugins. All right, so if I were to start with a very basic concept of CNI, and if I were to establish a network within my own container, the very first thing that I need to do is I need to come up with a network namespace, right? So I believe the last speaker in his talk talked about or touched the point about namespace. So just wanted to open up this question, if anyone can define namespace in its simplest term for me. Like, what is a namespace? And it's a Linux term. It's not a container devised term. All right. So let me try to explain the term namespace in a very layman term. So we are in this True Digital Park on 3rd floor, and then we are attending this talk in this definite area. Now, if there is only just one talk happening on the entire 3rd floor and we want to conduct another talk, we might have to move to another building altogether or maybe another floor, but that's not efficient way of running things. So what we did, we created physical isolations by creating barriers, and then parallelly, concurrently, we are running multiple talks on the same floor. As of now, to be precise, there are 5 talks, right? So the intent is to not let this talk interfere and influence any of the adjacent talks that are going. And the way we are doing is, we are just creating barriers, physical barriers, big tall barriers, and then every small section, every small segment is being powered by all the necessary things. A stage, a podium, mic, the setup, screen, etc. And then this is replicated in all this isolations, right? So in the Linux term, because you have multiple processes, multiple applications running simultaneously, concurrently, there is a high chance that if there is no isolation provided, they might start interfering or influencing the adjacent concurrent running processes. So how do you ensure that they are not doing that, right? So you create namespaces, you isolate them, you segment them, and then you create virtual isolation for them to run concurrently and simultaneously. So when I'm doing that, what exactly I'm doing is I'm creating separate usernames. Every namespace will be having its own username, its own file system, its own SE/Linux policies, its own network policies, its own security policies, its own usernames, host names, right? So all of that thing. So building upon this concept, this namespace is not just required for applications or for processes, it is also required for the network as well. So at the network level, we create network namespace. Again, I might want one application to be running in one particular subnet of my topology, and another application to be running in another subnet. So instead of creating multiple pods or containers, how about I just go and create multiple network namespaces. So similarly, every individual network namespace will be having its own NIC, network interface card, will be having its own socket, port, IP table, rules, firewall D, NF tables, etc. And then they will be running on different protocols within the same container, right? So in order for me to establish a network within a container, the very first requirement is to be able to create a network namespace. Then once that is created, the CNI should be able to create a bridge network between the host device and the container device. And then once the bridge is created, it should be able to create Ethernet pairs, right? So again, the Ethernet pair, one end of it is connected to the bridge of the host and the other is to the container end. And then why virtual? Because we are at the container level, nothing at that level can be or will be physical. So even the network, even the Ethernet cards or the network interface card would also be virtual. And then once that is done, you attach a virtual Ethernet to a namespace. And yeah, so you attach the other end of it to the bridge and assign the IP addresses. And once the IP address is assigned to a particular pod, to a particular container, that is when the container comes up and the pod goes live. Now, if, okay. So before that, this is a sample code, a sample algorithm, right? Now this requirement is there for almost every known major standardized container runtime interface, right? So be it Docker, RKT, Mesos, Kubernetes, Cryo, you name any CRI. So every CRI would require some sort of standardized code or standardized algorithm, and then this code, this standardized, if we try to create a standard out of it and start shipping with every other CRI, That is called as plugin, right? Now, if I were to create my own CNI, which is very much possible, my CNI should be able to play certain roles which are most mandatory, which something that the CNI cannot skip, right? So let's try to understand a very finite, non-exhaustive list of such roles. The first is it must be able to create network namespace. We understood what exactly a network namespace is in great detail in the previous slide. And then since there will be multiple network namespace, it should be able to identify the correct namespace for a particular container, and it should be able to attach the container to its proper network namespace. And then it should be able to invoke the network plugin whenever a container is added or whenever a container is deleted. And yeah, so again, whenever I'm configuring something, I would be configuring it in terms of files. So it should accept a proper standardized format. JSON is one such format. You can go for any other format as well. And yes, one important thing is it should be able to support CLI, because I, as a network admin, should be able to, or developer, I should be able to interact with the said CNI. So it must give me some accessibility, some way to interact with and perform at least the three most major important operations, that is add, delete, and check. So add as in add the container to the network namespace, delete as in terminate or remove, and then once I have added or deleted, I must verify. I need to be able to verify whether the said container has been properly attached to the network namespace, and hence for that there should be a check operation as well. And then once that is done, it should be able to return the results in a specific format. Again, it can be text, tabular, JSON, whatever it is. So before moving on, a quick recap for all of us. I assumed there would be students, so just try to create the slides accordingly. So as of now, what we have seen is the definition of CNI. Quickly, it is a specification that defines how to configure networking for Linux containers. A collection of a sample algorithm or a code is nothing but a plugin. And then examples of plugin that we saw in the diagram were like Bridge, IPVLAN, and some of the other third-party plugins that we'll touch in the later half of this demos in slide. Okay, moving on to the second topic, the second half of this talk, that is IPAM, IP address management, right? Now, if you are doing any business that involves assigning IP address to a container, revoking IP address to from a container, managing, monitoring, tracking IPs, you are basically dealing with IP address management. You are dealing with basically IPAM. Now, in this particular slide, I'm not talking from the Kubernetes perspective. I'm just trying to define IPAM from in a plain, simplest networking vanilla possible way, right? So yes, so if you're doing anything or touching anything with respect to assigning, revoking, tracking, monitoring, managing IP addresses, it is IPAM. If you think, or if you are in a notion that there is a device, you attach an IP address to it and just go about your day, that's not enough. No, sir, that's not definitely enough. So if a device or if a container is terminated, there should be a methodical approach, or there should be a systematic approach or a defined set of steps that the IPAM should function. For example, if the container is terminated, the network admin must ensure that the IP address has been revoked and properly sent back to its IP address pool, and it is not reused before it is thoroughly cleaned up, right? So all this set procedure should exist, and for that reason, IPAM should be adopted. And yeah, so IPAM also is an integrated suite of tools. It integrates DHCP and DNS as well. Now, from the Kubernetes perspective, let's try to understand what IPAM exactly, whether it exists or not. First of all, whenever we are talking about Kubernetes, we're actually talking about orchestration, right? So we need orchestration because the number of pods and containers grew beyond our control. The very reason that we are now dealing with tens, hundreds, thousands, millions of containers is the reason that we are required to orchestrate them. There are pods. Every pod will require an IP. Every service will require an IP. when a pod tries to interact with other pod, it needs an IP. When a pod tries to interact with a service, it needs an IP. When a pod tries to interact with the external network, it needs an IP. Apart from pods and services, there are other resources within Kubernetes that require IP, right? So there is a high need of IP address, and whenever there is there are many multiple million factors of containers and pods. So there should be, again, a need to manage, track, allocate, revoke, monitor those IP addresses. So Kubernetes has a built-in tool to be able to perform IP address management, and that is kubeproxy. That is a built-in tool that comes by default, but it comes with certain limitations, right? So what those limitations are, like the kubeproxy is not in a position to scale beyond a certain level, right? So it has a load balancing capability, but it's not smart enough in the sense that it does not look after the pod's health or pod's load and then divert the traffic. So it has certain limitations. Now, there are some challenges given by or posed or possessed by the IP exhaustion. So back in 1980s, when we came up with this concept of IPv4, we divided the 4 octets into 8 bit each, 32 bits, and that gave us about 4.3 billion IPs. So by 1980s, it seemed that those many IPs would have been sufficient, but in next 10-15 years, it was very clear that those many IPs would not be sufficient, because by 1995, 1990 around, we understood one important factor, that IPs are not assigned to users, they are assigned to devices. One user can handle multiple devices. Look at your phone and your device, and then just try to understand how many IPs are assigned to your Ethernet or NIC, and then you'll be amazed. So every single user is handling multiple IP addresses, extrapolated to the level of the cluster, right? So IP addresses, it was very early identified that they would be limited in space. So there are a lot of challenges when it comes to IP address exhaustion. First is network congestion. If my pod is ready, but IPs are limited, they would try to fight, and there would be a race condition, or maybe the network admin might be tempted to reuse the IP address and assign it to an upcoming pod. But the previous pod was not terminated cleanly, so there is still a live access to the previous pod's sensitive info, right? So that also possesses the security risk. And then if my resources are enough, if my pod is ready, but IP addresses are not enough, my pod would not go up, my container would not go online, and that is also another factor that would contribute to difficulty in scaling. And then increased complexity with less number of IP addresses, network admin may try to, or may be tempted to adopt complex ways to as a workaround, for example, overlay networking, or maybe multicast IP addresses, right? So, or maybe NATing. So this definitely introduces some complexity. So as a result, Kubernetes tried to throw in some built-in plugins. The first one is host local. Host local, what it does is it basically allocates the IP addresses locally. It is good for a small scale cluster, but not for an enterprise level large scale cluster. Again, DHCP is another built-in plugin for IPAM. But the thing is that DHCP would require its own DHCP server, which again comes with its own overhead, right? So it is an overhead if we are supposed to manage another DHCP server. So I personally wouldn't want any such overhead. So given these limitations with built-in plugins, Kubernetes finally started supporting third-party open source IPAM plugins. So this is some of the glossary of those, or collection of those plugins. On the left-hand side, these are some of the built-in plugins that are shipped locally by Kubernetes. And then on the right-hand side, these are examples of the few completely open source CNI plugins. We'll start with Bridge. Again, it's been adopted or fetched from the Linux terminology, and it tries to create communication between your host device and your network and your container network. Host local, again, it tries to assign IP addresses locally. MAC VLAN is something that would uniquely try to assign a MAC address to a particular container so that it would communicate as if it is a physical device. IP VLAN is working similarly as Mac VLAN, but yeah, but it uses less resources in terms that it uses same MAC addresses for multiple containers. And then loopback is very essential because lot many applications are coded in such a way that they assume that there is a presence of loopback IP address. So that is required. Static and DHCP, they assign dynamically or in a static sense. Now there are some of the examples of third party. Flannel is a lightweight option. If your cluster is lightweight, if your cluster is small scale, Flannel should be a good option. Calico provides networking and security solutions. And then again, there is another third-party network plugin that is called as Canal that combines the capabilities of your Flannel as well as Calico. And then there is Cilium. It uses eBPF at the backend for high performance. There is Weave for mesh networking. There is OVN Kubernetes. It is called as like open virtual Kubernetes to provide advanced networking features. And then there is SRIOV for improved performance or for high performance. Again, this is not an exhaustive list. There are much more open source CNI plugins coming up in the market. So yeah, based on your use case, based on your network topology, based on the architecture, and if you are very much concerned about your performance, you have certain options. If you have a small cluster, you have equal options. So yeah, so that was about it. And then there's a recap. And yeah, I'm Parth Goswami. I work at Cloudera as customer enablement engineer and been working with in the networking space for a long time. Thank you so much for the talk.
Thank you, Parth.
Yeah, any questions?
Have time for some questions before we get to the last session of today. So welcome anybody, any questions, networking, IP address management in the virtual environment? Yep, over here. Thank you very much.
Thank you for the awesome session, Parth. I really got to know about networking more detail because I was really confused basically about the networking. It is like a network in the head basically, and it is all get exhausted. Thank you for that. I just had a small question, like how someone can decide which CNI plugin is suitable for their architecture, or maybe while deciding the CNI plugin suits for their entire portfolio.
Again, I would recommend to start by looking at your topology, the number of devices, the use, the daily use cases of your containers, as in how many containers are supposed to come up in a specific day or over a weekend. And then based on that, if you require high performance for a specific time, but okay performance for a long time, based on these factors, you can decide. I won't be able to like advocate a particular name, but yeah, based on such factors, try to question yourself and then try to look at the features of all those plugins one by one, try to have a comparative analysis, and that is how I would decide a best suitable plugin for my architecture.
Yeah, sure. I have some follow-up. That answers best thing, but can we use multiple CNIs for the internal containers and then external applications or something like that? Like we can get the best out of that, right? Because sometimes some organizations has partnership with some of the third-party providers, network providers basically, and that leads to themselves to not exhaust the current IP addresses quota assigned to themselves. So instead of that, we can use the open source one for the containers. Is that possible?
Absolutely. The major proprietary solutions, networking CNI solutions, the major proprietary CNI solutions, they often ensure that you're vendor locked. You're not allowed, or maybe they make you design your architecture in such a way that you are not supposed to talk to any other third-party CNI plugin which is not designed by them. That's the reason this is an attempt to throw some light on the open source options, which are definitely very flexible and allow you to interact with multiple CNI plugins from third-party, as well as, again, you can use some of the already existing, already inbuilt shipped plugins by Kubernetes as well. So in open source world, that's definitely a big yes.
Okay. Thank you.
Okay. Sounds like there'll be some more conversation on that. But yes, if no other questions, we'll close it out here. Oh, one more as a follow-on. Yeah.
Yeah, you asked, can we use multiple? Mhm.
Vendor lock-in is like there present. There is a vendor lock-in actually. He mentioned about that, and that will lock ourselves. So he said that at the end that you can use the open source alternatives for that, and you can use the mixed ones, I guess. The default one is there, right? So you can implement default ones, and for the application you can use the other ones.
Yeah,
Those
and
are-
then most of them can be used internally as well. Yeah, yeah. And then you always have the ability and flexibility to come up with your own CNI. So in the one of the list I mentioned the must necessary rules that the CNI must play. So like, if you're just following that and try to keep it simple, you can definitely come up with your own CNI as well.
Okay, networking can probably keep us busy for a few hours, so we'll take that offline. But thank you very much, Parth. Appreciate your session.